All right, so here we're going to do 2.2 equations, some more examples. I only got done with that first example on the first video. So here, let's do another example with an initial value problem. So initial value problem. Okay, we're going to get our differential to be x over y. Negative x over y, and our initial condition is y of 4 is going to be negative 3. Okay, so again, here, first step, right, we want to separate. So we have y dy equals negative x dx. Okay, separate and then integrate. So I'll get y squared over 2. And I always like to keep the c on the x side, x squared over 2 plus c. All right, if we multiply everything by 2, now again, 2c, still constant, so it doesn't really matter. Now, it's up to you when you want. I don't want to solve for y yet. It's up to you when you want to solve for y. Solve for c, sorry. But I'm going to use this now, right here. So I'm going to say, okay, we have negative 3 squared equals negative 4 squared plus c, right? So here I'll get 9 equals negative 16 plus c. So c is going to be 25 for my solution with that initial value, okay? So now if I plug that in, I'll get y squared equals negative x squared plus the 25, right? And now, if I take the square root, I'm going to do plus minus. Square root, I'm going to rearrange it, 25 minus x squared. And the next question is, and this is what I was saying about the other example, finding c, we could leave it as, if you're adding two constants, still c, e to the c is still c. All these values. But when you're looking for a specific equation to go with the point, you have to decide, is it going to be plus or minus? And the way you do that is go back up to your initial value. And since y of 4 equals negative 3, just think about plugging in 4 in for x, right? That would give you 16, so that would give you a square root of 9. We want it to be a negative, right? So I know for this specific initial value, I'm going to use the negative root 25 minus x squared as my solution. Okay, so that's an initial value problem that I gave, that we did. Okay, we could also try this one. Okay, so let's see if we could get, now this is not an initial value, I just want to show separate and integrate. Okay, this is a little tricky one. So we'll separate, let's bring the y squared minus 4 equal to dx this way. So this is what I want to go over, is how do you integrate that, right? So let's rewrite it like this, 1 over y squared minus 4 and dy. Now I know that I could factor the denominator and break this up into two different fractions. So this is called partial fraction. So if I break it up like this, now it doesn't matter the order that you put it in. I just picked y minus 2 first, right? My goal is to figure out, well, what is a and b? Okay, so to figure that out, rewrite it this way, where it's almost like do your common denominator with the two fractions, right? So here I'll get 1, this is always the same, but here I'll get a times y plus 2, right? And this will just be y squared minus 4, and then plus b times y minus 2, y squared minus 4. So now since all the denominators are the same, we know that 1 is going to equal a y plus 2 plus b y minus 2. Okay, so here, make y -2. It'll get rid of your a value, and plug that in here, and you'll get 1 is equal to -4b. So we know b is going to be -1/4. Do that with 2 as well, and you'll get 1 equals 4a. So b is going to be 1/4. Okay, and now you can integrate this, right? So you would have, right, what was a? Whoops. A is positive 1/4. So here we're going to have 1/4 over y minus 2 plus a -1/4 over y plus 2 dy, and then that'll equal dx. Okay, so once you're at that step, now we could, let's just take out that 1/4, right? Let's take out the 1/4, and this way you don't have to see it. Make sure you keep the sign. Okay, so integrating this side, very simple. You just get x plus c. I'm just going to leave that there. Here I'm going to get 1/4 ln y minus 2 minus ln y plus 2. Okay, and then here you could see that we could break this down, or do a couple of things here. Let's multiply by 4. So over here it's just going to be 4x plus another c, right? And here, remember your rules. It makes things a lot easier. Your rules with minus or plus with logarithms. So this is ln absolute value of y minus 2. The minus makes it a division y plus 2. Okay. And now how do we solve this? So again, going back to our rules, use e. So I'm going to get y minus 2 over y plus 2 equals e to the 4x plus c. So it'll look like that, which then means that you could bring down the c, right? Because it's going to be e to the 4x times e to the c. But again, this e to the c is still just constant. So I'm going to write it this way. What? Y minus 2 over y plus 2 in absolute value equals c e to the 4x. Okay. So you have this notation, and we want to know how to solve this whole thing. So the way we could do this is, let's get rid of this absolute value, because it's kind of embedded in that c. Like, I will never mark off, and actually I don't think WebAssign either, if you have that big c there for x, because getting the plus or minus here with the absolute value, you would know when you plugged in your initial value what that would equal. So the one thing that I do want to show you guys is, how do you solve this? How do you solve this for y, right? So this is just back to algebra. So what I'm going to do is cross multiply or multiply both sides by y plus 2. So I'll get this, c e to the 4x y plus 2c e to the 4x. No, 2. That's it. Just 2c e to 4x. Yeah. Okay. And then what you want to do is bring all the y values to one side and bring everything else to the other side. So here I'm going to do y minus c e to the 4x y, right? So I'm subtracting c e to the 4x y to both sides, and I'm adding 2 to both sides. Now I could factor out that y on the left side. Actually, let's also factor out a 2. Okay, and now I could divide both sides by that 1 minus ce to the 4x, and I'm left with, I'm going to rearrange some stuff here just so it looks neat. And that would be your solution. All right. Okay, let's do another initial value problem. Okay, let's try this one. E to the 2y minus y times cosine x dy over dx equals e to the y sine 2x. And our initial value is just y of 0 is 0. Okay, so let's try to get the solution for this differential. All right, so let's bring all the y's together. So I'm going to divide everything by cosine x and an e to the y. Yeah, and then I'm going to bring the dx over. So watch, I could do this all in one step, but remember, you're just rearranging it so that, you know, the y's stay together. And then the x's stay together. And just watch your notation. Okay. All right, so two things here. One, what is sine 2x? Okay, because I don't really like, the angles aren't the same, right? So if you look here, you have a 2x and you have an x, angles aren't the same. So I'd rather keep it where it's all just x. So that's going to give me 2 sine x cosine x, right? You could see it like that. And then you could see that the cosines will cancel out, and we're just left with 2 sine x dx, which is a lot easier to deal with. Over here, I'm going to simplify. Think of your rules for exponents, right? Same base, you subtract. So here you get e to the y minus e to the negative y, and then we're doing dy with that. So now we integrate. So a few things here. I mean, the right side's very simple, and that term's very simple. It's this term that we need some help, right? So integration by parts. So what I'll do first is let's break it up where we have the easy ones on the outside, and inside we have our integration by parts. All right, so, okay, so here, okay, so here, always pick, I'll show you a couple methods with this one. Always pick the easiest value to derive, or almost like you're trying to get rid of it. Usually it's just going to be your algebra one, so that's y. So this is dy. The derivative of y is dy, so that's your u. Whatever's left over is your dv. I always do it this way because you want to pick u and dv first, then take the derivative of u and the integral of v. Okay, so here you get a y. We said this was dy. E to the negative y. dy is left over, so that's negative e to the negative y is your antiderivative. Okay, remember integration by parts, uv minus v du. And if you, the first part is u dv. Okay, so that's integration by parts if you forgot that. Okay. So let's see what this is. So minus, so I'm taking the minus from above, right? Don't lose that minus sign. And I have uv, so negative y e to the negative y, uv, minus v du, which is dy. And then just, I'm going to bring down everything. And now we could go through the problem. Okay, so that e to the y is easy. That's just e to the y. All right, we're going to change the sign here. I'm going to get a plus y e to the negative y. So be careful on this one, right? Because it is changing, right? You're distributing that negative in there, right? Making that a positive, okay? And then you have another, it's going to wind up being a positive because you have four negatives that are going to appear here. So it's plus e to the negative y, and then equals negative 2 cosine x, and then I always leave the c on this side, okay? At this point, you know, with the initial value, let's just use that value and plug in and solve for c. So I'm going to use the y of 0 equals 0, right? So let's see. So y and x are both 0. So e to the 0 is 1 plus 0 plus 1 equals negative 2 cosine 0 plus c, which we know cosine 0 is 1. Okay, so that's just negative 2, right? So c, so negative 2 plus c equals 2. So 4 equals c. And then just plug back in for your c value. So here I'm going to get e to the y plus y e to the negative y plus e to the negative y equals 4 minus 2 cosine x. And that's it. All right.